சார் வந்திருக்கு
டாக்டர் சம்மந்தி கோனசிகி கெஸ்ட்னு இருக்குங்க.
இந்த ஒரே நிமிஷம், ஏன்னா அவங்கள பிரசன்டர்னு மாத்தி விட்டாதான் நேத்து இருக்கிற ப்ராப்ளம் வராதுங்க சார்.
எஸ் 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 சார் சார்
இந்த
டூ த
பண்ணிடுறேன்.
பிரசன்டர் क्वेश्चंस. ఓకే సార్.
అది నడుకుంటే మొదలు వచ్చాట ఏంట దాంట్లో దీంట్లో కట్టించి నేను కుదరదు కట్టినే అయితారు పోయినాడు 5 மணி டீ கொண்டாங்க
வருது தமிழ்லயும் சொல்றாங்க சார்
வேற சொல்லுங்க
சார். மேடம் இன்னும் உள்ளார வரலைங்க சார்.
சார் மேடம் எனக்கு டிஸ்ப்ளே வராங்க சார்.
ஏதுங்க சார்?
அவங்க வீடியோல வந்துட்டாங்க சார்.
ஆனா எனக்கு இங்க ஒண்ணுமே வரலைங்களே சார்.
இஸ் மேம் இஸ் அவைலபிள் விசிபிள் ஃபார் வீடியோ சார்.
அவங்கள கொஞ்சம் பேச சொல்லுங்க சார்.
மேம் ப்ளீஸ் செக் த வாய்ஸ் மேம். மேம் குட் மார்னிங் மேடம். மேம் குட் மார்னிங் மேடம்.
குட் மார்னிங்.
சார் பிரசாந்த் சார் இஸ் மேம் இஸ் டாக் இஸ்
இந்த ஒரே நிமிஷம் சார்.
ஓகே ஓகே.
இது காந்திய வெந்தன் சார்.
Video is not clear.
Yes ma'am, video is clear ma'am. Video is clear, audio is clear ma'am.
But not my side.
இருக்காங்க சார்.
Any streaming problem ma'am for your side?
No sir. No sir.
Okay okay okay.
இப்போ அவங்கள மாத்தி விட்டோங்க சார்.
ஓகேங்க.
என்ன preliminary அவங்க செக் பண்ணலாம் மேடம் அவங்களோட இது எதுவும் டிஸ்ப்ளே ஆகுதா என்னன்னு.
ஓகே மேம்.
Okay.
Okay ma'am, okay ma'am. Wait ma'am, I introduce for okay, let us start. Okay. Sir, well, Professor start sir. Right.
Yes sir, yes sir.
Okay, okay. Thank you. BT Starking College of Program jointly organizing virtual start training program on data science and statistical applications held during 15th March 21st to 22 March 2021. Today short-term training program on data science statistical application day 3. Past 2 days have successfully granted the program. Right now, the great pleasure to introduce the today's special address, Dr. W.G. Samanthi Konasinghe, Academic Director and Statistical Consultant, Institute of Mathematics and Management, Sri Lanka. Ma'am is education qualification BSc of Bachelor of Science, Physical Science from University of Pendaria, Sri Lanka. Postdoctoral Diploma in Industrial Mathematics, University of Sri Jayamandra, Sri Lanka. Master of Science, Applied Statistics, University of Pendaria, Sri Lanka. Master of Business Administrative, Gujarat University of Sri Lanka. PhD in Statistics, University of Pendaria, Sri Lanka. AM is the associate with several academic programs, Bachelor of Science, Postgraduate of Diploma degrees, Master of Degrees, Master of Business, Doctoral programs, Philosophy. The MAM is the literacy of knowledge of associate with software and applications, knowledge of data analysis, Minitab, SBase, eViews, computer programs, Minitab, or SAS, and also big data handling by Matlab and Excel. The MAM is published for list of publications. There are several of publications, more than 200 of journals, indexed journals, reputed journals, and
Several
also
programs,
conference putting of
philosophy.
several of programs. More than the MAM is programs participated and presented. MAM is the newspaper articles. 2nd June 2018, Does Market Beta Revealed the Truth? The Sunday Observer Weekly newspaper, Lagos, Sri Lanka, that depend upon page 17th. The testimonial of applications, the Associate Fellow of ASA, USA, the members of magazines from ASA, USA, 2018 and 2020. The international awards, MAM is got from international award, IMR of Best Scientist Award, 2019 November, Best Paper Awards, Thailand, November 2018, Best Paper Award from Singapore, May 2016. The members of bodies is ASA, ISSL, Sri Lanka, NSF of Sri Lanka. The academic profile of posting, the consulting statistical consultant of ASA, USA, the editorial member of American Journals of Theoretical and Applied Statistics, and advisor member of STR, Scientific and Technical Resource Association, Technical and Scientific Conference Committee members, STRA, Scientific and Research Association, the advisory board member of International Conference on Contemporary Issues in Business Management 2021, India, editor of Chief Journals of New Frontiers in Mathematics and Statistics, Journal of New Frontiers in Economics and Business, Journal of New Frontiers in Healthcare and Biological Science, Journal of New Frontiers in Education and Social Science, published by Institute of Mathematics and Management, Sri Lanka. MAM is the associate with several activities in academic activities, conferences are International Conference on Mathematics and Biological Science 2020 October, conferences are International Conference Social Science 2020 December, the Australia, from Australia, both of programs. The conference are ISCSR Berlin International Conference on Science and Technology Research 28 January 2020 Berlin. The conference are International Conference Science and Technology Research, the 15th May 20 from Malaysia. The conference are once again March from Melbourne. Conference are March 2019 from Singapore. Keynote address, International Conference January 2021 from Berlin, Germany. Keynote address, International Conference December 2020 from Melbourne. Keynote address, again December, Melbourne. Keynote address. The title of is The Role of Mathematics Over All the Circums, 15th May 2020. Keynote address, again 2020 from Melbourne. Keynote address, March 2019 from Singapore. Keynote speaker, India, September 2018. Planetary speaks, International Conference, India 2019. Again invited speak, speak 2019, and again International Conference of Special Address speak, India 2020. The resource person, contributor talk, chief guest. There are several activity. The MAM is associated with academic bodies and research counseling, associated with several programs. The ma'am is the National Awards Best Actress Annual Drama Festival University of Valencia, Sri Lanka 1992 and also Best Actress Annual Drama Festival University of India, Sri Lanka. The ma'am is the several academic working since 24 years. Institute of Mathematics and Management, Sri Lanka, Academic Director, Asia Pacific Institution of Information Technology, Senior Lecturer, Royal Institute Senior Lecturer, Kingston College of International Faculty, University of Colombo Visiting Faculty, South Asian Institute of Technology Medicines Visiting Faculty, American National College Part-Time Lectures, Imperial Institute of Higher Education Visiting Faculty, Visiting Lectures, Informatics Institute of Higher Education Visiting Faculty, ICFEA Education Lanka Visiting Faculty, Graduate Institute of Science and Management Visiting Faculty. Ma'am is the teaching faculty of mathematical modes, uh, depends upon core applications, statistical applications, research methodology, operation research, financial management, management science. And ma'am is the research associated with the area of interest, mathematics, statistics, modeling development, applied mathematics, statistics, mathematical modeling for economics and finance. Time series, knowledge of applications and classical music. The ma'am is associated with school and community activities, musician, drama, producers and scripters and arts. Now I request Dr. Samantha Sringer from Sri Lanka. Ma'am, once again, welcome you, ma'am.
Thank you very much. Am I audible?
Yes, ma'am. Right now is audible, ma'am.
Visible?
Streaming is some problem, ma'am. Voice streaming problem is, ma'am.
Oh, voice is clear, no? Right.
Yes, ma'am.
Okay. First of all, I would like to thank you for inviting me for this great event.
Ma'am, voice is not clear, ma'am.
Yes. I don't think anything wrong from my side.
Okay. Prasad sir. Prasad sir.
சார்
ஏதாவது டெக்னிக்கல் இஷ்யூஸ் இருக்குங்களா மேம் சைடுக்கான?
இல்ல கரெக்டா வருதுங்க சார்.
ஓகே மேம். ஓகே மேம், கேரிங் மேம். தேங்க் யூ மேம்.
Because like even like I can hear this. Shall I join?
Yes ma'am, join ma'am. Can you join ma'am?
I asked, but I said, shall I rejoin?
Yes ma'am, no problem. Rejoin ma'am.
Okay, because the echo and
யூடியூப்ல லேட்டா தான் வரும்.
Professor, how is it now?
Yes ma'am, right now ma'am.
Now it's clear, no?
Yes ma'am, right now is clear ma'am.
Now the both video and audio are clear.
Yes ma'am.
All right. Okay, then I will share the screen.
சவுண்ட் கிளியரா இருக்கு பாருங்க.
Professor, is the screen sharing?
Okay ma'am. It's not streaming ma'am.
It's clear now? Is this screen sharing?
No, ma'am. It's not streaming, ma'am.
Really? What's wrong with that? Professor?
Yes, ma'am.
Now that I am trying to share the screen,
Okay,
so
ma'am.
I click on open share tray,
Okay, ma'am.
and then the window is appearing down, screen share desktop window. So I'm supposed to click on that, no?
Okay, ma'am. The share of the one of options is there, ma'am.
Yeah, then another window is coming. Want to share the contents of your screen, choose what you want to select, and okay.
Sir.
You click it, madam. You click and
Sir,
share, madam.
sir, ma'am is given the presenter position, ma'am. That is better to options.
Ma'am has a option, sir.
Okay,
Just click the window and share, madam, and open our PPT, madam.
Now, can you see my screen?
No, ma'am.
No, madam, not yet, madam.
Not yet. Okay.
It's not streaming for your presenting portion, ma'am.
How is it now? One second.
No, madam, not visible, madam.
Not visible?
Madam, please click share tray option and
Under what?
screen share desktop window,
Yes.
and then click
Please.
your entire screen and share.
That means I have to put into the screen sharing, like 1 second.
Yes, madam. The window is open. You click your entire screen option and click share button.
Oh, sorry. Ma'am, left from fourth stage of button is the time and video, mic. First position time, second position video, third position mic, and fourth position is one of the option is there, ma'am. Sharing up slide, ma'am.
Madam, please unmute your mic, madam.
Hello.
Now,
Ma'am is not streaming for
yeah,
PPT,
that's
ma'am.
why there is a problem, Professor. When I try to access the camera and the video,
Okay, ma'am.
now the both are unmuted. So share screen.
Sir,
When I
technical
start
questions, ma'am
sharing,
is regarding to.
Madam, Microsoft Teams not allowed both video and PPT, madam. If you start
Ma'am,
presentation,
that
any
is
one platform use, ma'am. Can you
muted, madam.
share for
okay.
our PPT, ma'am?
So now that
Both of
I'm on the can allow the share your screen, your entire screen. What should I click on?
Click, madam. Click the window and share, madam. Click share, madam.
Okay, share.
Open our PPT, madam.
Screen.
It is visible, madam. Please open our PPT.
It's visible.
Visible, madam. Please open our PPT, madam.
Right. Okay. No problem. You can see the first heading, data science for real life.
No, madam.
Please open your. Yes,
Okay,
ma'am.
madam. It is clear, madam. It is clear. It is visible, madam. It is visible, madam.
Ma'am, visible, ma'am.
Everything is clear now.
Ma'am, visible, ma'am.
Well and audible.
Yeah, visible,
Okay,
visible.
then I'll start.
Okay, ma'am. Okay.
Okay, right. Good morning, everyone. So I'm Dr. Samanthi Konarasinghe from Institute of Management, Sri Lanka. First of all, I would like to thank the professor for Professor Gandhiya to inviting me for this great event. Today, I am going to talk about data science for real life. Data science. Data science is a multidisciplinary approach to extracting actionable insights from the large volumes of data collected. Data science encompasses preparing data for analysis and processing, performing advanced data analysis, and presenting the results to stakeholders to draw informed conclusions. We all know, most of you are mathematics or statistics people. We all the scientists, all the researchers, we are doing data analysis. So, what is then data science? We are dealing with big data. Like in a data analysis, let's say you all use software. Some use SPSS, some use Minitab, and some use eViews. With the help of software, we do data analysis. But when the data, in every situation, large volumes of data we have, how to process them. At once, you can't enter the data. Say, for example, simply, if you are collecting, let's say there is a reservoir. You develop that reservoir every hour. So the 24 hours, you are measuring that. Let's say it may be a water level, or maybe you are measuring wind speed. Every hour, you are measuring the wind speed. So then per day, if you are measuring every hour, you have 24 data points per day. If you are measuring every minute, then a large number of data. So likewise, if you collect this data for several years, and software, then we need to prepare the data for analysis, and we have to process them. That means if we have hourly data, we may have to convert them into daily data, and then the monthly data or week data or annual data also. When the data are there, our existing software are to process them and prepare them for analysis. So what the data science do is helping for that. data science is going beyond the data analysis. It prepares the data and process them for analysis. After that, after preparing and processing, we do data analysis, but later on I will tell you how data science is more advanced than data analysis. Now, at present, the data scientists are in big demand. Who is data scientist? In short, data scientist is someone who is better at statistics than any software engineer and better at software engineer than any statistician. It is somewhat weird definition. A data scientist is better in statistics and better in software engineering than a statistician. In short, this is an interdisciplinary area. Data science is an interdisciplinary area. So if you are a data scientist, you must be good in 3 things. Data science is based on these 3: mathematics, statistics, and computing. Interdisciplinary thing. So in mathematics plays a vital role, actually the main role in data science as well as other sciences. Data science is also basically depend on mathematics, because both statistics and computing depend on mathematics. Therefore, mathematics plays the main role of data science, and statistics and computing as well. So like mathematics is a disciplinary help to understand all the other subjects. As I said earlier, statistics and computer science, they both are based on mathematical methods. Hence, statistics and computing rely on mathematics. So, the data science as well. But simply speaking, data science is the mathematics, statistics, and computing. All 3 contribute to data science. That's why we say a data scientist should be better in statistics than any software engineer, but better in computing than any statistician. So, if mathematics is the major or the main thing in data science course, it is worth seeing what is mathematics. We all know mathematics, but actually what is the real meaning of mathematics? The term mathematics is taken from the ancient Greek word mathema. Meaning of it is the subject of instruction. Mathematics is, the meaning is subject of instruction. That is, mathematics is not a subject. It is a subject of instruction. It is used to understand all the other subjects. Let's say, so entire engineering discipline is based on mathematics, statistics. It is developed on probability theory, but the discipline statistics also purely based on mathematics. Then physics, some rules are there in physics, some laws, theorems are there in physics, but they all are developed and explained through mathematics. Even biological sciences, medical sciences. Simply speaking, let's say you go to a doctor, you are sick and you go to a medical practitioner. You go to a medical practitioner. So he prescribes some medicine and he says, take 2 tablets in every 6 hours. Every 6 hours. How does he know that it has to be taken in every 6 hours? Considering the rate of change of the concentration of that medicine in the human body, it is being calculated by exponential decay, exponential function. So that is like someone has done that experiment and given that, okay, you give 2 tablets, the concentration of that one goes almost to zero in 6 hours. Before that, take another 2 tablets. That is the medical science, biological science, everything depends on, that means explanation of every discipline is based on mathematics. Therefore, mathematics is known as mother of all sciences. No wonder mathematics is known as mother of all sciences. Some say the queen of all sciences, but I don't like that, because queen is quite kind of dominating the ordering. But mathematics is not like that. Mathematics helps everyone, like a mother looking after all the children. Same way, mathematics is looking after and helping the disciplines. So not like a queen, mathematics behave as a mother. Professor?
Madam, sorry for disturbance. Slide is not moving, ma'am.
What is not moving?
Slide, ma'am. Or your slide is not moving, ma'am.
Now you are in which slide?
Yeah, slide. Only your single position is there. Only one slide is data science for real time. First slide is only showing, ma'am.
So from my side it is moving.
Okay, ma'am. It's not our time is streaming, ma'am. That time the call, ma'am. One registered person from Dubai, ma'am. They called, ma'am. Sir, each slide is not moving. It's only static positions.
Okay, I will stop share and start it again.
Okay, sir. Okay, ma'am. Okay, ma'am.
How is it now? Professor?
Madam, only the first screen is displaying.
Okay, I'll quickly change the slides and see whether is it moving now.
No, madam.
No.
Yeah, it's moving right now. It's moving now.
Ah, it's moving. Okay. Let's see. Is it moving now?
Now the screen share has stopped, madam.
Sir.
Is the screen share is not there now?
Unmute பண்ணிக்கலாம் சார் உங்களை. என்ன சாருக்கு வந்து அவர
What is happening now?
இருங்க சார். இப்ப பண்ணி பாருங்க சார். இப்ப ஆகுதாங்க சார். Thank you. இப்ப மேடம்
your screen is not visible, madam.
Not visible?
You share it once again.
அவங்க பேசிட்டு இருக்காங்க. இல்ல அவங்க இதெல்லாம் போய் எங்கிட்ட பேசிட்டு இருக்காங்க.
Madam, only audible, ma'am.
Yeah, screen is not visible even to me, ma'am.
Yes, ma'am.
From my side, it says Teams Microsoft is sharing your screen.
Oh, okay, ma'am.
But it's not visible, madam.
Technical persons regarding to madam issues.
Screen share desktop.
Madam, now you open your presentation.
Yeah, it is already open.
Madam, can you close it once and open, madam?
Stop share
I mean,
and
sharing. You unshare it and then
I did it several times. Let me close everything and try.
Sometime it works if you leave the meeting and rejoin, madam.
Is that so?
Yeah, I have experienced that. If you can just once.
Because the Microsoft team is not very helpful like this Zoom. Okay, let's see again. How is it now?
It's visible, madam. Now.
Move it and see.
Yeah, please move it. I am able to see the slide. What is data science?
What is the data science slide, ma'am?
What is the data science?
Ma'am, can you check up and down
Now,
now? That is slide is
yes,
move
that's
or up down?
I'm trying. Now what do
Check
you
it, ma'am.
see?
Yeah, ma'am. Yes, ma'am.
Now what do you see?
Same
Yes,
slide.
ma'am. The same slide, ma'am. What is the data science slide? There is no dynamic slides, ma'am. Only static
Like
portions.
in from my side, it is moving. Who is data scientist?
Oh, technical persons?
I will try to rejoin. I will.
Yes,
I
ma'am.
don't know some.
Okay.
Yeah.
Ma'am, once you share the screen, please click on the page down button. Hello? Your voice is not on.
audio.
Mic is not on. Switch on the mic, please.
You unmute the mic, ma'am. It's muted.
Yeah.
Okay.
No audible, ma'am. Yes, ma'am.
Now
Can-
I am clicking on that arrow open share tray.
Yeah, yes, ma'am. That is used only
And
that
select the
option.
desktop, madam.
Yes, I select the desktop window,
Desktop.
right?
Mm.
Then another.
Then can you
I'm supposed to do.
select the presenting positions? No, ma'am.
Now tell me, share your screen, your entire screen or application window.
Madam, you just share the application, madam. Only you select that window, share the application. From that you select presentation, Microsoft PowerPoint.
Now the Microsoft PowerPoint is open in my browser, in my window, and
in the you click that share screen option, then you click specific window. In that you select Microsoft Office, PowerPoint.
But the problem is like when I keep the presentation open, and then when I click on your entire screen, I am not seeing my presentation.
Wow. Technical persons.
That's the problem. Like I first opened my presentation on my window, and then when I click your entire screen, click on that, I don't see the presentation.
You just stop the sharing, and in that share screen you find entire screen and another option as window. You see the two options.
Yeah, there are two options: your entire screen and application window. Then
You select that up. No, don't select the entire window. You just select the application.
Okay. Ah,
From that, you select Microsoft PowerPoint.
how is now?
Yeah.
Yeah, ma'am. Now it's
Yeah.
okay.
Okay,
Now
ma'am.
do page
Check
down,
the
madam.
up and down, ma'am.
Ma'am,
Go
page
to
down.
up,
Page
Click on
down.
page down.
up and down. That is check it, ma'am.
There is a page down button is there.
Okay,
Can I
ma'am.
click?
Yeah, the page down is from the computer.
Yes, ma'am.
Yes.
Computer, ma'am. It's
The keyboard.
desktop.
Madam, your
The
screen is
keyboard.
visible. You can present, madam.
Is the screen moving now?
No, ma'am. It's not moving, ma'am. Only static position, ma'am.
Ma'am, please click on the page down button
Page
in
down
the
button, ma'am.
keyboard. In the
Page down
keyboard.
button
Keyboard.
where?
Keyboard, madam.
Keyboard,
The
ma'am.
keyboard.
Keyboard, ma'am. Desktop keyboards.
Like from my side, it is moving.
Wow.
I don't know like, what is wrong with the thing because it is moving from here.
Ma'am, please.
Please click on F5 button otherwise. Full screen. Please click on F5.
Shift F5 or F5 button, ma'am.
Hello. Ma'am, we lost you.
Yeah, yes. The last is the URL problem. Maybe I think URL issues. Maybe there, ma'am. The end of. Once again, I.
I mean, nobody is to help her. I don't know.
That is the simple option is there, sir. That is the show the presentation option. Then click to select the options there. Entire screen and particular screen.
Madam, now your screen is visible. You just press F5 and start changing.
Yeah, changing from my the computer buttons now.
Yeah, ma'am.
Yes, ma'am. The up and down button is there, ma'am. The keyboard is there, ma'am.
Yeah. Now is it moving?
No, ma'am. Only dynamic. Sir, static
That's the
position.
problem. Like from my side, it is moving.
Madam, can you double click on any other slide? To the
Double
left.
click on any other side.
Yeah, maybe second slide or third slide.
How is it?
No, your
ma'am.
arrow is not going
Associated
to the
with
second
the.
slide, right?
Yes, ma'am.
Shall I quickly email you the slide set? Then can you operate from your side?
Yes, ma'am. Send it, ma'am.
You can
Ma'am, send it
through-
to my mail ID, ma'am. I will operate, ma'am.
Because some technical
ma'am.
issue is there. So
Okay,
I will
madam,
quickly email the slide set and you operate from your side.
Yes, ma'am. Send it me, ma'am.
Just
Both
email
of
it.
WhatsApp and mail, ma'am. I will operate, ma'am.
I will email to
Okay,
from my Gmail.
Okay, madam. Okay, madam. The Gandhiya Vendhan at yahoo.com from mail ID and both of WhatsApp, ma'am. I will manage, ma'am. My side, ma'am.
Okay. Professor, check mail now. I send it.
Yes, ma'am, I got mail.
Okay. Operate from your side.
Yes, ma'am. விஷுவல் ஆகுங்க பாருங்க.
எப்படி இருப்ப எப்படி இருப்ப கவர்மெண்ட் இருப்பியா என்ன
Hello? Hello? Hello?
Yes, madam.
Are you sharing from your side? I
Yes,
tried
ma'am.
again. I tried again from my end. What is going on now in your side? See this. See whether the slides are moving now.
No,
Anyone,
madam.
please tell me.
We are saying only
No,
once.
no. Okay, then let's only one slide. No, so okay. Let professor to share from your side. I'll stop sharing from here.
Hello. Sir, we have changed you as presenter, sir. You can present it now.
Hello?
Sir, Vendhan, sir. We have changed you as presenter. You can present it now, sir.
Professor, can you share the screen from your side?
Yes, ma'am. I'm trying, ma'am. Okay, ma'am.
Just open from your side the presentation, and when I go ahead, I will seek the help from you and to move the slides.
Okay, madam. Okay, madam. Okay, ma'am.
Sir, now you can present, sir. Sir, you can present it now.
Prasad sir. Prasad sir, allow me, sir.
Yes, sir. We have made you presenter.
சார் இப்போ நீங்க உள்ள இருக்கீங்களே சார்.
சார் ப்ரெசென்டிங் ஷேர் எனக்கு ஆப்ஷன் ஆக மாட்டேங்குது சார். ஷேர் த ப்ரெசென்டிங் வந்து ஆப்ஷனே எனக்கு ஒர்க் ஆக மாட்டேங்குது சார். ஹலோ ஹலோ
சொல்லுங்க சார்.
சார் எனக்கு ப்ரெசென்டிங் ஆப்ஷன்ஸ் இருக்கு பார்த்தீங்களா, ஷேர் த ஆப்ஷன்ஸு. அந்த வீடியோவும் மைக்கு பக்கத்தில் இப்போ ஓகே இப்போ ஓகே
சார்
இப்போ ஓகே இப்போ
இப்போ
ஓகே
வந்துச்சா சார்?
இப்போ தான் வந்திருக்குங்க. இப்போ ஓகேங்களா சார் உங்களுக்கு?
சார் ஸ்கிரீன் வருது சார்.
ஓகேங்க.
நெக்ஸ்ட் ஸ்லைடு போடு. ஓகே சார், சேஞ்ச் ஆகுது சார்.
It's
ஓகே
moving also.
மேம்.
Okay, now I can see.
Okay ma'am, okay ma'am. Is up and
Please,
down, okay ma'am. Okay ma'am.
Yeah. Now put into the presentation mode, please.
Okay madam. Ma'am, can you start ma'am?
Yeah, but put into the presentation mode. It is the slide is just in the slide mode, not in the presentation mode.
Sir, please press F5.
சார் F5ல தான் இருக்குங்க சார். F5 போட்டு என் ஸ்க்ரீன் பெருசாக தான் இருக்குங்க. என்னோட டெஸ்க்டாப்ல ஸ்க்ரீன் வைடாக தான் இருக்குங்க சார்.
Sir, you can go to slide shows, the tab, sir. Slide show tab.
Okay.
At the top, home, insert, design, animation, and
yes,
then
design is there beginning of
slideshow. Yeah, begin slideshow.
Yeah.
Hello. Hello.
That bottom the
okay,
icon.
Class la presentation.
Slideshows is beginning from. Okay. Correct, sir. Nice move, sir.
No, slideshow you have to begin, sir. You can say from current slide.
Yes, ma'am. Yes, sir. I given the beginning of slide, sir.
No. From current slide you can press.
Which
top,
slide?
Top second option.
Second options.
Yeah.
Move
at
on.
the top. From beginning, and then you can see from current slide.
Yeah. Yes. From beginning.
Press on that.
Otherwise, this is the second slide. The from the current positions. Right
No.
now
Don't
there,
touch. No. Go to top, sir.
Okay.
Can you see the icons for from beginning and then from current slide?
Yeah, from beginning. First option
that,
from
sir.
beginning. Second is the from current slide. Third is the customer slide.
Yeah,
okay.
Click on that. Click on.
Yeah, is beginning current slide.
Current slide.
Beginning.
Yeah, current slide.
Yeah, click
is
on
more...
that, sir. Double click.
Yes, ma'am.
You did not click it, sir.
Sir, I am operating, sir, my side. Is everything is my system is upside down. from beginning
Actually, sir,
side.
you have selected
Okay.
Yeah,
just
double
the
click.
first slide.
Yeah.
Double click
Is
on that, sir.
right now move. No, sir. Is my system is operating the same procedure, sir. Okay.
Madam,
Shall
from
we go
the
ahead in this way?
yeah, from the beginning side, click, then double click, the move, single click, move the another slide, sir. Next slide, go to my side, sir. My side is the moving the system, first slide, second slide, go to the other next slide, sir. That is no problem, my side of end.
Professor,
Tell me, sir, ma'am.
that like down the window, that next to the, just before that 68 percentage, there is an icon, no? Double click on that.
Yes, ma'am. In our system is
Yeah.
moving perfectly. First slide, second slide,
Ah,
everything is up
that
and
means
down. There is no problem,
same
ma'am.
thing. Same thing like from my side. No, earlier it was moving. Oh, so then shall we move with this one? Otherwise, the time is
This is
going
fine,
on,
sir.
and
This is fine, madam. We can see
Okay,
this.
ma'am. Ma'am, right now it's move, ma'am. Okay, ma'am.
yeah, the screen is moving. Only thing is it is not maximum, but it doesn't matter. Shall we go ahead with like this?
Yeah, please,
Okay,
madam.
ma'am. That is the slide for what is the data science, ma'am.
Yes, I mean it is not taking the presentation mode. It is just in the slide form. But I will go ahead then.
Okay, ma'am.
Okay. So once again, we'll start. So today's topic is data science for real life, and I said, what is data science? Data science is a multidisciplinary approach. It is a combination of mathematics, statistics, and computer science. So the difference between data analysis and data science is, in data analysis, by using some software, maybe SPSS, so Minitab, OEV, so whatever, we do data analysis, and then we come to valid conclusions. We help the real world problems. Yeah, is it okay now? Okay. Then who is data scientist? Data scientist is someone who is better, someone good in statistics as well as computing. So a data scientist is someone okay, Professor, go to the next slide. Professor, please move to the second slide and third slide.
Yes, ma'am. Now is showing the who is the data science, ma'am. Currently is
okay, it might take, maybe this Teams is slow, because in my side it is again the what is data science. Anyway, who is data scientist? Data scientist is someone who is good in statistics and computer science. Professor, please move to the next slide. That flow chart is there. Two more, fourth slide.
this is okay, ma'am. History of mathematicians. What is the mathematician?
No. Ask the others. I am not seeing the slides moving.
Oh, what happened? Okay, ma'am.
Even we are seeing only what is data science slide.
Yes, the same is here. I am only seeing the what is data science.
So only presenter are able to move, but we are not able to see, I think.
Yeah, the same thing happened to earlier from my side. I could move, and I thought it is moving, but actually, like you from your side, it has not been moving.
Yes.
Something wrong with the system, I guess. The Microsoft Teams.
Sir, totally you are out. Madam, now is it visible?
It appeared and disappeared. Okay, now it is appearing. Yeah, it's moving. Are the others also?
Yeah, we could see it moving, madam. It came to the fourth slide, base of data.
Yes,
Now
ma'am.
it came to the presentation mode, right?
Okay, moving, sir.
Now it is moving. Now it is in the presentation mode.
Okay, madam. You can go on.
Okay, then please go to the first slide. I will restart, otherwise it will be not, it is a discontinuation. Okay. Professor?
Yes, sir. First
Yes,
slide.
ma'am.
Is it okay, madam?
May I start?
Yeah, madam. You
Yes,
can
ma'am.
start.
Start,
Okay,
ma'am.
let's go ahead. Hope this time we'll be able to continue. Right, I don't need to tell it again what is data science. Now you know it is a multidisciplinary approach between mathematics, statistics and computer science, where we are handling with large volumes of data. We prepare data for analyzing, processing, performing advanced analysis and presenting. Okay, Professor, move to the next slide.
YouTube போட்டாரா ஆமா அவ்வளவுதான்.
Then who is data scientist? He is someone who is good in statistics as well as computing, software engineering. That means he is not very good in statistics as a statistician or software engineering as a software engineer, but he is good in both areas, statistics and computer science. Please move to the next. Next slide, please. All right. So the data science, it has three bases: mathematics, statistics, and computer science. Next, please. Next slide, please. So, as I said earlier, mathematics is the base of every discipline. It is a subject of instruction. So, let's go back to the history of mathematics in brief. Mathematics, the subject of instruction, is that word is taken from Greek word mathema. Next, please. Next slide, please.
Is it okay now, madam?
I think go to that history of mathematics slide and start sharing, because it got now. Yes, go to that slide and start sharing. Okay. Right, now it's in the correct slide. So, if you look at the history of mathematics, the ancient mathematics are Babylonian, Egyptian, Greek, Roman, Chinese, and Indian, and so on. That means the mathematics was begun from Babylonian. Babylonian mathematics, it was developed in Mesopotamia. The base of that Babylonian mathematics system is 60. You know, now we are using base 10 system, but the Babylonian system, it was base 60. So that's how, using 60 seconds, 60 minutes, 360 degrees, that was originated from the Babylonian mathematics, as they used the base 60. So the Babylonian mathematics evidences are found in clay tablets. These two pictures are two the clay tablets of that. Click. Move that slide. Move to the next one. Okay. Babylonian, move to the next slide. Just click. Yeah. So both Babylonian and Egyptian texts mention the Pythagorean triples. You all know Pythagoras theorem, something we learn in college. Pythagoras theorem. That was the beginning of the mathematics as a demonstrative discipline. It begins in 6th century. So thereupon, the ideology of mathematics has been born and so later on, some European mathematicians of the scientific revolution, Galileo, Kepler, Leibniz, Newton, Fermat, Pascal, and many others contributed to mathematics. So Pascal and Fermat, they set the groundwork for the statistics, probability. Based on that one, statistics was developed. Until the ancient Romans introducing mathematical modeling or the applying mathematics in real life, it stands as a pure mathematics. Later on, the ancient Romans, they introduced mathematical modeling. So the mathematics, mathematics has a lot of areas. So it is like a tree. Mathematics is like a tree. It has see the bottom one, logic, set theory, number systems, geometry, algebra, and so many branches are there. Statistics, some say statistics is not a branch of mathematics. In a way it is true because it is developed based on the probability theory, yet it is totally depending on mathematics. Therefore, some define statistics as mathematics of uncertainty. It is not wrong. Statistics is mathematics of uncertainty. So then statistics also has become, in a way, it is a branch of mathematics. So this huge tree is the help of all the disciplines, including data science. Next slide, please. So mathematics. Professor, I can hear big noise. Some other people also talking. Interrupting, no? Please mute the others. Okay, the pure versus applied mathematics. In pure mathematics, we learn axioms and theorems. Like as I said, the Pythagoras theorem, it is a theorem. Theorems have to be proved. Like we can prove the theorems mathematically, but axioms we have to accept as they are defined. That is the difference between axioms and theorems. Then the applied mathematics or the mathematical modeling, it is use of mathematics in other disciplines. When it says other disciplines, every discipline. It can be biological science, management science, or the physical sciences or engineering, everything. The mathematical models can be classified in many ways. I will briefly explain some more important things. Static versus dynamic and deterministic versus stochastic. Static and dynamic models. If a mathematical model has a time-dependent component, it is known as a dynamic model. If it does not have a time-dependent component, it is called a static model. Say, for example, if you take a multiple regression model is a static model. Whereas when you take time series models, they are dynamic models. If you take Malthus model or Gompertz model, they are dynamic models as a time-dependent component is there. Then another classification is deterministic versus stochastic models. Deterministic models, okay, move to the next one. Deterministic models are not associated with any randomness. That means, the real life is full of uncertainty. We cannot say anything for sure. We don't know what will happen in next moment. So the deterministic models are unable to capture the uncertainty in real life. Conversely, stochastic models capture the randomness. In other words, stochastic models are referred as statistical models. So when we say statistical model, that is a stochastic mathematical model. Next slide. Right. This is the process of mathematical modeling. This diagram illustrates how a mathematical modeling is begun. First, number one, you see a real world problem is observed, and that means, say for example,
Madam, others please mute your volume, please. Mute your audio, please.
Sir, I think disturbance is coming from BLK Prasad.
Madam, you can unmute and speak, madam. Now I had muted everyone. You can unmute and speak.
Okay, I did now. Please share from this slide. Right. Process of mathematical modeling. Say for example, you are working for some company and you you are selling some goods and you observe that the sales are going down. That means you observe some symptom, not the problem actually, you observe some symptom. Then you start thinking, as in the second one, what are the reasons? What are the root causes for this sales drop of sales? Then you start, you speak to the customers, you speak to the workers and the management. Likewise, you get some information, and based on that, let's assume you devise a regression model. You assume the sales depend on the customer satisfaction, the wages of the workers, and some other government taxes or some other problem. Based on them, you devise a mathematical model. Say, for example, you devise a regression model. Tentatively, you think a regression model would work, or you yourself develop a new model. Then you go to the mathematical. What you do is you make use that model for some calculations or estimations. After that, you can see this balance, the scale. There, you are trying to see whether your predicted or the estimated outcomes tally with the actual outcomes. That means your predicted sales and the actual sales for some months. Please go back to the previous slide. Still, I am not done. Previous slide, please. So you try to balance you see whether your model is good, and if this balance is there, that means if the predicted and observed outcomes tally up to a certain extent, and if it passes by the statistical test, your model is good. So you use it for real life situation, real life forecasting. If not, you go to the mathematical model and refine. Actually speaking, this data science is really effective at this point. If the model you selected is not good, then refining the model is a difficult task for a data analyst without the support of the computer programming. Because say regression, you tried with the regression model, it did not work, then you don't know what to do. Maybe you use transformations and whatever it is, if it does not work, you have to refine the model. There you have to write the programs, because your SPSS or Minitab or Excel, they are programmed for certain models, but not like when you are doing something new, when you are refining the model, you need the help of computer programming. So in the process of mathematical modeling, the role of computer programming is vital. With that only, you can do a real good job and obtain or develop a really good model. It can be a mathematical model or statistical model. Either way, the role of computing is crucial in refining the model. So this is the irrespective of the field, whether it is biological science, agriculture, meteorology, engineering, irrespective of the field, this is the process we are using in any research, academic research or any other field research. This is the process. See whether in scientific research we are not going out of this picture. Please, next slide. Next slide, please. Right. So with that introduction, I will tell you my journey. That means I have developed some new techniques with the help of mathematics, statistics, and computer science. So that means I have done the data, I have used data science. So I will tell you how I did. That will help you to understand the difference between who is statistician and who is data scientist, and how these things are interrelated. When it comes to if I briefly say about me, the Professor Gandhiya introduced me. So my first degree, it is BSc in mathematics. I learned pure mathematics, applied maths and chemistry. So anyway, from my child days, I used to read a lot of books, and I was a painter. From my small days, I was very good in painting. So even in the university, I was a violinist. I was a violin player in university orchestras, and I was the drama producer and then actress. So I kept all these things together. I mean, after all, above everything, I did meditation. So meditation, and later on I practiced yoga also, the Indian origin yoga. So with all these things, like my academic background is in this one. First is BSc in mathematics, then postgraduate diploma in industrial mathematics. That means I went to the pure and applied maths in the university, but the real applications I learned from industrial mathematics. Then I got the master's in applied statistics, and I got master's in business administration also. That is a totally different area, but I became a real applied mathematician or applied statistician because of this master's in business administration program. Then only I could really understand what is the requirement of mathematics to this field and that field. And it allowed me to bridge my mathematics and statistics knowledge to any field. So finally, I got the PhD also in statistics. And then from that point onwards, or even before that, I have been practicing mathematics, statistics, applied mathematics, applied statistics in almost all, every field, lot of fields. But I could manage with existing software. That means I used to use Minitab, SPSS. Not SPSS is not much actually. Minitab, SAS, Starter. I used to use those software for my data analysis and the other purposes, research purposes. Next slide, please. Next slide, please. Right. So in my PhD, this is the turning point of my life actually. With that background, actually, you could have seen that I am a multidisciplinarian. I am a scientist as well as an artist. So when I was searching for a research area for my PhD, I got to know that there are big problems in the share market. You know, the stock market or share market. It plays a vital role in the economy of any country. Sri Lanka or India or any country, the role of stock market is crucial. So then this problem, my research problem was related to the Sri Lankan share market. So my PhD topic was model development for stock returns. Next slide, please. Next slide, please. Right. The share trading share market or stock market. India, like Sri Lankan stock market, of course, is a small market, Colombo Stock Exchange, but the India has two big markets. The one of the oldest stock markets in the world is Bombay Stock Exchange. Like in every corner of the world, all the investors know about the Bombay Stock Exchange. Why is that? It is affected to nearby markets as well as faraway markets. So not that big, but even in Sri Lanka, the share market is an important part. So in general, it is known that a healthy stock market has been considered indispensable for economic growth. That means the share market shows the sign of or the direction of the growth of the economy of a country. Therefore, investors concerned about investing in the share market. In share market, there are like when the investors invest in the market, they get the return in two ways. One is like let's say you invest in one company, say Maharaja company, you invest some money. If the company has profits, if the company gets profits from their business, they will give some returns to some dividends to their stakeholders or the shareholders. In addition to that, like when you invest in share market, by selling your shares, buying and selling shares, you can get another yield. So the stock market investment are like really profitable than other fields. Therefore, the investors are willing to invest a lot of money in the share market from the investor's side to get a high return. But from the economy as a whole, when the investors invest in the market, the government have money to run the country, like to start the development projects, especially when the foreign investors are coming into a country. That means the foreign money is coming to the country. So that way, it helps for the economic growth of a country. In a share market, we are talking about two things. The previous slide. Previous slide, please. The risk and return, they are the most important concepts in stock markets or financial market. Financial market is another name for the stock market. Return is when you invest say you invest 100 rupees, if you get 150, your return is 50 rupees. Risk is what? There is a volatility, or like when you invest 100 rupees, maybe you get like when by selling if the share prices go down, you will be able to sell it at 50 rupees. Then you get a loss. That is the risk. Share market prices are going up and down, and that volatility is very high. Therefore, the risk and return are very important concept in financial markets. Hence, the forecasting risk and return have a very the prominent place in share market. Next slide, please. Next slide. Okay, this one, right. So the stock market forecasting or the share market forecasting mainly divide into two parts. Like they are done by statistical techniques and soft computing techniques. So the statistical techniques again divide into two parts as fundamental analysis and technical analysis. Fundamental analysis and technical analysis. Then the soft computing techniques also used for stock market forecasting. Some techniques are artificial neural network, neurofuzzy, and so on. So some people combine these techniques. That means statistical techniques and soft computing techniques. That also very effective. So the next slide, please. Fundamental analysis. Fundamental analysis, like there's a like real discipline began in 1952 with the modern portfolio theory of Markowitz. It was one milestone of fundamental analysis. So the combined output of this Markowitz, Sharpe, Lindner, Black, and many others, known as the capital asset pricing model. So you can see the expected return of the I company equal risk-free rate of return plus the beta into RM is total market return, RF is the risk-free rate. Here, this beta is the covariance of one individual company with the total market return. It's divided by the variance of the market return. So this model, the development of this model, like these researchers got the Nobel Prize for introducing this one. It is such an important concept. Like in this one, here the it is looks like a regression model, but actually it is not a regression model. Here the independent variable is the beta. Beta or the covariance divided by the variance. That is the independent variable. This Rm minus Rf, it is a constant. So if you take a linear model, if we take y equal mx plus c, that linear model, then the gradient. So this model was really helpful in forecasting share market return. Generally, this was used for individual companies. Actually speaking, in share market investments, individual company forecastings are very useful because the investors are investing in individual companies. So this one, move to the next please. Next slide, please. Right. This beta coefficient that in share trading in Sri Lanka as well as other countries, this beta coefficient is used to measure the risk of returns. That formula, capital asset pricing model, is used for forecasting returns, and beta coefficient is used to find the risk of returns. Then if the rule is if beta equals 0, that means then there is no risk in investing in, like these betas are calculated company wise. So if beta equals 0, there is no risk in your investment. If beta equals +1, average risk. And if beta is greater than 1, high risk. If beta is less than 1, less risk than the other companies in the market. Likewise. In the Sri Lanka, the share trading is conducted in Colombo Stock Exchange. There, we also use the same model. So here the research problem of mine was CAPM or capital asset pricing model assumes a linear relationship between the return and risk, return and beta. However, the CAPM has failed in many markets, including the Sri Lankan. The reason is this works only if there is a linear relationship between risk and return. So you know what the linear relationship is. When there are relationship between variables, always they are not linear. But the CAPM or the capital asset pricing model assumes a linear relationship. So when it is not there, the model fails. The same thing happened in Sri Lankan market, but the Sri Lankan share market was depending on the CAPM. That means making blind forecasting about the market. That was the research problem of mine in my PhD. So I am telling you these things to tell you how I became a data scientist, how I moved from statistics to data science. Please, next slide. In my research, the primary objective was develop some statistical models for forecasting Sri Lankan share market returns to develop an indicator to compare the relative stability or risk of individual companies in share market performances. That they were the primary objectives of my study. There were some other secondary objectives. However, these were the primary objectives. Next slide, please. So in my study, by the literature reading, I found that, as I said, I tested based on the literature. I tested these models. Capital asset pricing model, the top one in the big box. Expected return equal risk-free rate of return plus beta coefficient, that covariance upon variance thing into RM minus RM. So first, I tested this model for large number of companies in the Sri Lankan share market, the total market, and large number of companies in the Sri Lankan share market. And I found that the CAPAM fails because there is no linear relationship between returns and risk in the share market, Sri Lankan share market. Therefore, I concluded that capital asset pricing model does not work for the Sri Lankan share market. Then I took the vector autoregression models or VAR models. You know, the VAR models or the vector autoregression models predict the future by looking at the lag or the past of one variable. That means if y is a random variable, please mute the others. If yt is a random variable and yt minus 1 is one lag variable, yt minus 2 is the second lag. That means, let's say for example, if yt is this month, yt minus 1 is last month. Say the sales of this month is yt, sales of the last month is yt minus 1, and the one before that is yt minus 2, and so on. So the vector autoregression models, not only the legs of the same variable, it considers the legs of some other variables as well. Like in share market, if y is the return, yt minus 1, yt minus 2, they are the leg variables of that variable return, and xt minus 1, they are the legs of trading volume or market capitalization, other variables. So the VAR models find the relationship between a variable with its own legs or another variable and its legs. So I checked the VAR models also in Sri Lankan context, that also failed. Then I move to the decomposition technique. A well-known, this is called the classical approach of a time series. In this one, in decomposition technique, we model a time series. That means we model a series. We divide a series into 4 components: trend, seasonal, cyclical, and irregular component. Trend is what? The long run movement of a data series. Maybe it is upward or downward, linear or non-linear. So the seasonal pattern, seasonal variation is if there is a variation in your data series seasonally. That means, like say, sales go up in the festival season. That is seasonal variation. Generally, seasonal length is less than 1 year. Maximum is 1 year. So less than that, less than or 1 year is the seasonal length. Cyclical variation is long time variation. Like say, if every 5 years, if something happens, if heavy rains comes in every 5 years time, that is a cyclical variation. An irregular component is the random error component of a model due to nature. So in decomposition modeling, there are 2 techniques: additive model and multiplicative model. So I tested both additive and multiplicative model again for large number of companies in Sri Lankan share market. It was difficult task. Of course, it was difficult task, but I managed to do with the existing software. I used Minitab, and I managed to do it. Then when that also fails, I went to ARIMA. ARIMA means autoregressive integrated moving average technique and seasonal autoregressive integrated moving average technique. What ARIMA says is the present value depend on past legs of the variable and past errors. What is error? Error is simply actual minus forecast. Today, the today's value may depend on yesterday's value, day before yesterday's value, and yesterday's error, day before yesterday's error. That is the ARMA model concept. Then in this ARIMA and SARIMA models, the data series should be stationary. It is a must. What is stationarity? The data series should have a constant mean and constant variance. Otherwise, the ARIMA cannot be used for that series. So sometimes the data series do not follow satisfy the criterion of this stationary. In such a situation, we take differencing. We take differencing of the series. If the differencing is used, that model is called ARIMA. The basic is ARMA, autoregressive and moving average model. But if the differencing is used to get the stationary of the series, we call it ARIMA. I tested ARIMA and seasonal ARIMA in my case as like taking large number of companies. Again, I use the Minitab software, and this model was satisfactory up to a certain level. Not that it was not satisfactory. Right, not like decomposition, VA or CAPAM. ARIMA models were satisfactory up to a certain level. But there were large number of data series where they were not stationary. Even with differencing, I could not make them stationary. And in some cases, the series was stationary, but it did not satisfy the model validation criterion. That is, in ARIMA or any of these statistical models, we have to check the normality and independence of residuals. Epsilon T, residuals should be normally distributed and independent. Some of the fitted models did not satisfy this normality and independence criterion or both. So those models cannot be recommended for forecasting. As that problem was there, I tried the arch-graph approach. Basically, I have tried with all the existing statistical techniques in my research. My objective was finding the best model and improving it for better forecasting. However, arch means autoregressive conditional heteroscedasticity. GARCH is generalized arch models. So what that does is, like, arch and GARCH models are different from other models. Like decomposition or VA models or CAPAM or ARIMA, SARIMA, they can make the forecast for a data set straight away. But when it comes to arch, let's say we use a vector autoregression model. We use a vector autoregression model and find that model is fitting, but the errors are not independent. That means errors have some pattern. Then arch models can be used to model the error component. That is combining. It is like a hybrid approach. First we test some model, maybe VA model or decomposition or something, or the moving average model or MA model or AR model. If the errors are not independent, we extract that and try to model the errors by arch or GARCH. So I tried that also. That failed. It was a complete failure. Arch and GARCH effects were not there in my data series. So by the time, like, it has been taken several years, and I have tested all the models. I have tested all the existing statistical models, and the statistical models are actually the technical models. At the beginning, I said stock market forecasting were done in two ways, by statistics and the soft computing. Statistical models we divide in two parts as fundamental and technical. So the CAPAM is a fundamental model, and some improvements of capital asset pricing model are there. That Pharma and others have improved CAPAM, and those models also I tested. That is fundamental approach. And then the technical analysis. These time series models, I tested all the time series models. ARIMA was satisfactory up to a certain extent, but not very high satisfaction was there. Next slide, please. So that was the time to think about a new development. Because when all the existing techniques did not work, I mean, there was no way of improving ARIMA, because I didn't see a way of improving ARIMA. Actually, Archgaki also have been combined with ARIMA. That also didn't work. Then I thought of developing a new technique, finding a new technique to address the Sri Lankan stock market problem. So I managed to, after so many years struggle, like combining mathematics, statistics, computing, and actually management also. I managed to develop two techniques called, I named them as circular model and circular indicator. Later on, like I got the PhD for this, and later on, I found some weaknesses in circular model, and in 2018, I improved that one to overcome the weakness and name it as a Sama circular model. So I'll come to that later. Let's move to circular model. Next slide. Right. The circular model. The circular model was developed on based on mainly three things. Fourier transformation. Your Dutch people, you know what is Fourier transformation. Theory of uniform circular motion. That is physics. We learn theory of uniform circular motion in physics. When a particle is moving in a horizontal circle, there are two rules, two laws, the vertical circle and horizontal circle. Here I use the motion of a particle in a horizontal circle. And in statistics, we use a technique called least square method. That is, when in any statistical model, to minimize the error, we use least square method. That is, simply we are finding the extracting the error component, use partial differentiation in minimizing the error. Like, you know, by differentiation, we can find the extreme values of a function, minima and maxima. If for two variables, we find the minima and maxima in one way. If it's a function of more than two variables, we find it by partial differentiation. So the least square method is based on partial differentiation. Then this circular model was developed on Fourier transformation, theory of uniform circular motion, and least square method, that is partial differentiation. Next slide, please. So the Fourier transformation. Fourier transformation can be used to transform a real valued function fx into series of trigonometric functions. That's what the Fourier transformation said. The Joseph Fourier, the great finding of the Fourier is that he says a real valued function can be transformed into series of trigonometric functions. So the Fourier transformation has two versions, the discrete version and continuous version. So the discrete version of the Fourier transformation is this. Fx is a sigma of minus infinity to plus infinity an e to the minus k theta, exponential function, the decreasing exponential function. That's what the Fourier said. That means a1 e to the minus k theta, that way, from minus infinity to plus infinity. Next slide, please. So according to the De Moivre's theorem, e to the minus k theta can be written as cos k theta plus I sine k theta. You know, I is complex numbers. Then according to De Moivre's theorem, e to the minus k theta function can be written as cos k theta plus I sine k theta. Then the Fourier transformation can be has modified as fx. That real valued function is a sigma from k equal 1 to n. This n can be infinity also, but let's say k equal 1 to n, ak cos k theta plus bk sine k theta. Simply speaking, the Fourier transformation is given as some real valued trigonometric functions, cos k theta and sine k theta. That is combining the Fourier transformation with the Grimoire theorem. I'm not going to explain you how it has been done. So the Fourier transformation, when making this change, when modifying the Fourier transformation, the uniform circular motion of particle also considered. Next slide, please. If we look at the motion of a particle in a horizontal circle in brief, if a particle is moving in a horizontal circle, C omega is the angular speed, and that is rate of change of theta. Omega is d theta over dt, rate of change of the angle with respect to time. By integrating it from 0 to theta, that means completing one circle is starting from theta equals 0 and coming back to 360 degrees. So if we take any other point between 0 and 360 and integrate, we get theta equal omega t. We can find the constant also, like then we get t equal theta over omega. So the time taken to one complete circle, the time taken to complete one complete circle is known as the period of oscillation. Period of oscillation. So then at that, if one previous slide please. Stay in the previous slide. If the particle has complete one circle, then the theta is 2 pi degrees. So the period of oscillation is 2 pi over omega. Then we can express omega as 2 pi over t. Omega is 2 pi over t. So that is a relationship between the period of oscillation and the omega, angular speed. Next slide, please. So the sine and cosine functions. If we consider the sine function and cosine function with this reference circle, you will see we are explaining the same thing. The motion of a particle in a circular path and the motion in a sine function or cosine function, both are same. Just see, we are starting from 0 and we move to pi by 6 angle. That means if theta is pi by 6. So sine function, sine 90 is 1. That is, the maximum of the sine function is 1. And here I have shown the one complete circle which is completed in 2 pi. The cosine function also almost similar to that one. Only difference is when x is 0, cosine is 1. Other than that, within the period of oscillation, the particle complete one cycle means complete one wavelength. It moves in the distance of one wavelength. Next slide. So the period of oscillation, by the physics theory, period of oscillation equal to the time between two peaks or roofs of a sine or cosine function. Then what I did was, in my study, when developing the circular model, I found that I proved that if the time series has f peaks, that means when we plot the time series, if there are simple f peaks in n observations, then period of oscillation can be written as total number of periods divided by total number of peaks. That was the period of oscillation. So making that one, I modified the omega or the angular speed as 2 pi over t, that is 2 pi over n upon f. So omega is 2 pi simple f over n. That is a modification I did. Next. Next slide. All right. Okay. Leave here. So, as I said earlier, the discrete version of the Fourier transformation is this. This Fourier transformation, it has been widely applied in physics. explaining the regular, sometimes irregular waves also in physics. There, in Fourier transformation, the problem is like k is a defined value. Finding AK and BK, that means finding the heights of the waves, amplitudes. Finding heights of the waves is the problem in Fourier application of Fourier transformation. So in physics, it was done by laboratory experiments. Like, let's say they take a sound wave. So then to find the amplitude of the sound wave, they do laboratory experiments. Likewise, in physics and engineering, by the lab experiments, they found AK and BK. But my problem was, I am doing share market forecasting. Why I chose to use the Fourier transformation, I found that the share returns in Sri Lankan market follows an irregular wave-like pattern. That's why I started thinking, why not trying with the Fourier transformation? So then it happened, my challenge was how to find AK and BK. In physics and engineering, AK and BK, that the coefficients were found in lab experiments, but there was no way of calculating that one in my application, in my modified model. Next, please. So, like with my modification, the circular model is yt is sigma k is 1 to n, ak sine k, omega is 2 pi f over nt plus bk cos k 2 pi f over nt plus epsilon t. That is the Fourier transformation is this static model. Sorry, it is a deterministic model. It did not incorporate with the random error. So I proved that it can be modeled by as a statistical model, and now this was the circular model. So the model assumptions, I theoretically proved it, because the PhD in mathematics or statistics, we have to prove things theoretically. So I proved it theoretically, and the model assumptions were the yt. It is a continuous random variable, and t is greater than or equal to 0 because it is the time. K is a positive real number. That means it need not to be an integer. It is a positive real number. And like I said, there was a problem. Like my challenge was finding AK and BK, the coefficients. So I thought of using the regression technique, the multiple regression technique, to find AK and BK. That's what I suggested, to find AK and BK. Then if using multiple regression, now that this is completely like there are no independent variables actually. Like multiple regression, we have dependent variable and independent variables, but in my case there are no such independent variables. I treated these trigonometric series as independent variables, sine k omega t and cos k omega t series. Then model assumption was this series sine k omega t. If k is 1, sine omega t and cos omega t. If k is 2, sine 2 omega t and cos 2 omega t. If k is 0.5, sine 0.5 omega t and cos 0.5 omega t. Likewise, this series should be independent. That is the assumption of regression analysis. If I am going to use that technique, then my series should follow that one, though they are not real life variables. These sine trigonometric series were not real life variables. So, but I am using regression. Therefore, the one model assumption is this series should be independent. And once when the model is fitted, assume if the model is fitted, then the random error component, the errors should be normally distributed and independent. So these are the model assumptions of the circular model. Later on, I tested it, and I will tell you how I tested. Okay, please move to the next slide. So later on, like once when I tested, I found that the circular model is really applicable it is superior to ARIMA model. Now, up to that point, the ARIMA was the best, but it was also not up to a high level of satisfactory. So the circular model was really appealing into the Sri Lankan context, and I could forecast the Sri Lankan share market accurately and reliably. So I tested it using computer programming. I will come to that later. So, however, that was in 2016. My PhD is not very old. It was in 2016, but it took 8 years. You won't believe, like the generally PhD period is 3 years, but it took 8 years for me to do this thing because of this testing all the existing things and to bridge the fields. Mathematics, statistics, and management. I did an MBA in between. That means after 3 years, after 2.5 years of my PhD, beginning from PhD, I stopped it halfway due to lack of supervision. And then I did a master's in business administration to fill the gap. And with all these things, then I developed 2 new techniques. With all these things, it took 8 years. However, it is worth. So still, the circular model was enough. Circular model, and I developed circular indicator also. That was sufficient for the task. It was highly successful, but no one could find any mistakes in that one. But you know, we researchers always find faults with ourselves. If you want to become a good researcher, you must find faults with yourself. So I did that. I had a problem with my model. I was thinking whether it is really good for every application, because after the PhD, I wanted to apply it in other areas. And then I found that, okay, I with the circular model, I could capture the seasonal variation, cyclical variation very well. But the Sri Lankan share market returns did not have a trend. If the trend is there, what to do? That was the weakness in the circular model. So in 2018, I improved the model, combining with the differencing technique. I mitigated the limitation of the circular model by using the differencing. You know, the first difference of a series is yt minus 1. The second difference is yt double dash, that is yt dash minus yt minus 1 dash. Likewise, I went up to the deep order differencing and improved the circular model. Next slide, please. So this is the Sama circular model. What I did was, like, I combined this trigonometric series and the legs, the leg variables, then the improved circular model or the Sama circular model, that is present. I proved. I proved it theoretically. Yt equal yt minus b. That means yt can be yt equal to yt minus 1, leg 1 variable, plus yt minus 2, leg 2 variable, and so on, plus the trigonometric function and the random error component. This was the Sama circular model, which I improved in 2018. So the model assumptions are same as the circular model. Next, please. The second development or second finding of mine in my PhD is circular indicator. I developed it by using the Newton's law of a particle, Newton's law of a motion of particle in a horizontal circle. Actually, what I did was, like, if the particle is moving in a horizontal circle, like, my concept was this. I thought this way. The particle is moving in a horizontal circle or even a vertical circle due to the centripetal force. Physics we have learned, if there is no centripetal force, the particle will not move in that circular path. It will leave the circle. That's what the Sir Isaac Newton said. For a particle to move in the circular path or for a circular motion in either horizontal circle or vertical circle, there should be a centripetal force. If the centripetal force is not there, the particle will leave the circle. So based on the Newton's law, I started developing an indicator. Later I found that the philosophy of Newton's law of circular motion and the Dhamma wheel are almost same. You might see what this lady is talking about, because the first one's talking about the physics, Newton's law, and now talking about the religion. So I will tell you how it is happened. Now, what is the world's first religion? Hinduism. Actually, the Vedantism. The Vedantism is the first religion in the world. Later, it is converted into Hinduism. Your identity, the Hinduism. So this Dhamma wheel, or the wheel of the Dhamma, it is first introduced by Hinduism. It describes the life. The human life is described by this one. So then later, another great philosophers of India, they are the Mahavira and Lord Buddha, used the same wheel to explain their philosophy. Dhamma wheel is used in Hinduism, Buddhism and Jainism. So in these three, the explanations were slightly different. Still, the basic philosophy was same. But like, I'm a Buddhist, so as a Buddhist, I know how Lord Buddha has explained it. What Lord Buddha has said is, we are in a secular life. We are in a secular life. Like once we get good things in life, once we are healthy, once we are sick, in another time we are rich and poor. Like we get pluses and minuses in our life. That is because of this circular life. Why, according to Lord Buddha, why we are in this secular life? Because of our attraction. Attraction or desire. Now you see, you are attracted to your family members. If you are, like say, if you feel like you are going to die today, at once who come to your mind? Your loved ones. Maybe your parents, maybe your partner or children. They come to your mind because of that desire, that attraction. You can't you don't like to die, mainly because of your loved ones, due to attraction. So what Lord Buddha has said is, due to your attraction or desire, you cannot live the circular life. You cannot live this life. You cannot attain the supreme bliss of Nibbana due to your attraction. Then I found actually like comparing this Dhamma wheel and the sine function and cosine function with the Newton's law, I found that the philosophy of Dhamma wheel and Newton's law are exactly the same, no difference. So Newton said the particle is in this circular motion due to the centripetal force. If not, it is leaving the circle. Simply speaking, say you are driving in a circular path. You are driving in a circular road. If there is no force towards the center, if there is no centripetal force, you will skid. The friction is providing the force. If not that, you can't be on this circular motion. So the same way, like thinking about all these concepts, the Hinduism, Buddhism, and this Jainism philosophy in Dhamma wheel, and Sir Isaac Newton's law, I thought, okay, now I found the Sri Lankan share market follows an irregular wave-like pattern. Means by this Fourier transformation, according to Fourier, that wave-like pattern is related to the circular motion. So now I found that the Sri Lankan share market follows a wave-like pattern. That means they are in a circular motion, repeating. Ups and downs, the like things are repeating. Then there should be a force. Due to some force, these returns, share returns are moving in this circular path. So I developed an indicator to measure the stability of an individual company based on these things. Next slide, please. So the development of the circular indicator. Now Newton's law is the F equals ma omega squared. That is the Newton's second law of motion. F equals ma omega squared. So as I was, again, I proved it theoretically. I'm not going to explain the theoretical proof. That's, I thought, oh, that's centripetal force. F is, according to Newton's law, that force is mass into acceleration into omega squared. So as I used the per share return, that means return of one share. I took m as 1, that means mass of a particle is 1. I took the shares as particles, and then the mass of each particle I took as 1. And a omega squared, like modifying this one, I found the circular indicator. I defined circular indicator as r omega squared. That r is, sorry, that F equals ma omega squared, that a is not the acceleration, it is the radius of the circle. Sorry, I made a mistake. F equals ma omega squared, a is the radius of the circle. So then I introduced the indicator, which is named as circular indicator, that is radius into angular speed squared at time t. That means, like, if returns of a certain company moves in a circular path, it has some force keeping it in that circle. That centripetal force, that force keeping that stability in the market, can be calculated by r omega squared. That was my development. So, like, you know, in Sri Lankan share market as well as the other markets, risk is measured by generally either by beta coefficient of capital asset pricing model or standard deviation of the series, standard deviation of the price or return series. So the problem is the standard deviation. Standard deviation is really work for cross-sectional data, not for time series data. Why is that? With the time, the mean is changing. When mean is a variable, standard deviation also become a variable. So standard deviation does not remain constant. Therefore, we cannot use, like, though still the share markets use standard deviation as the measure of risk, but for time series data, it is not a good measurement of the instability or the volatility. For time series data, standard deviation is not a good measurement for volatility because the mean is not a constant throughout. Mean has distributions. Hence, using standard deviation to measure the risk of returns is erroneous. Though still the world is using that one, it is an erroneous method. So the beta coefficient was quite better than that, but that's what this Markowitz did. He introduced the beta coefficient and measured the risk of returns by using beta. So it is better than using standard deviation. There the problem is, if there is no linear relationship between return and risk, that does not work. So this method, my circular indicator, does not relate to any other variable. It is simply a mathematical calculation. So does not depend on any mean or any other parameters. Actually, this one does not depend on any parameter. Therefore, it does not have a distribution. So if for a particular company, let's say we take two companies, this F for one company is say 5 and the other company is 10. If this centripetal force is high, or if the circular indicator value is high, the stability of that motion is high. That is the idea. That means higher the circular indicator value, higher the stability of that company in the market. That's what I developed to measure the return and risk. Give me a second. Right. Then, okay. Now I was like, after so many years, I developed the circular model and circular indicator. And I was so happy. Why? I have developed two techniques, circular model and circular indicator. Now I thought, okay, I will be a Nobel Prize winner and I will be the world popular in for my findings, and this and that. I was daydreaming. After so many years, no, after about 6 years work, I managed to do it. But when I went to meet my supervisor, he said, okay, you have developed something theoretically, but how are you going to test this? You have to test your models with the real life data. You have theoretically proven it. True, I accept it. But what about the practical interpretation? Take large number of, like you tested for all the, like almost all the companies in Sri Lankan share market for ARIMA, VAR models and decomposition and everything. So do the same thing with your model, circular model and circular indicator, and show that your methods are superior to the existing techniques. So then I said, sir, there is no way of proving it, no way of testing it, because there is no program for this method. What to do, like existing software are not capable for that. So he said, yes, obvious, you are the one who found this technique. So other people did not know about your method, so they have not write any programs for that. So you do it by your own. Oh, see, then the problem is computer programming. I thought, okay, I was very good in Minitab. I thought, okay, I will somehow or the other way try to manage with Minitab. But testing for one company, like I was supposed to do it for about 200 companies. Testing for one company took more than 1 day. It is such a tiring job. Using Minitab, I had to make those trigonometric series, then testing the model. If fails, try another one. Likewise, it was a headache. The supervisor said, learn, use computer programming, RO, Minitab, RO, Matlab O, some programming language used. He said RO, Matlab. So to be frank, I hate computer programming. I have learned some computing in my postgraduate diploma in industrial mathematics, C++ and some database management and things I had learned, but I simply learned them to pass the exam. I didn't like computing. I thought I don't need computing. I am a mathematician. I am a statistician, so I can manage without computing. Therefore, I didn't bother about it. For so many years, I managed to skip that. I managed to neglect the computing. But the day came for me that no, I cannot move any further. My great findings, circular model and circular indicator, will be in my computer, will be with me. I can't bring it to the world without computer programming. So I started that, the hardest journey in my life. Moving in this thick jungle, it's a horrible journey. I started that, not knowing head or tail of computer programming, because what I have learned also I have forgotten due to my negligence. I started learning computer programming by myself. So I didn't have time to attend any lectures or anything. So I found some books and got the online help and learned R and Matlab. So I learned both, because I didn't know which one will work. I did R and Matlab both, and I found like I was interested more on Matlab. Then I go ahead. I went with the Matlab program. So that way I managed to test my models, circular model and circular indicator, effectively and efficiently by computer programming. So if not the computer programming, that again I am coming to the point where I started. I said data science is an interdisciplinary subject of mathematics, statistics and computing. So if handling large data, with large data processing, actually in my case, data processing was the time consuming job. So I was unable to do it with the existing software, with Excel or Minitab or SPSS. I was unable to do that part. So Excel was helpful up to a certain point, but not completely. So the only solution was computer programming. So it happened for me to face the challenge and learn the computer programming. With that one, I managed to test my circular model and circular indicator for large number of real-life data sets. Next slide, please. So then, with the help of computer programming, I managed to test the applicability of my model in my PhD study, and I found that it is superior to ARIMA. More than 85% of the sample of real life data sets, more than 85%, the circular model was applicable. Later on, I improved the SAMA circular model, and with that one, like more than 90% of the real life data sets, I could model with the SAMA circular model. So far, myself and some other researchers have applied the circular model and SAMA circular model in the fields of finance, hotel and travel, economics, gender studies, meteorology, healthcare and biological sciences, agriculture, and many more. Still, it is a new technique, so more applications are needed. However, this up to this point, like with the real life applications and the theoretical proof, it has we believe that this SAMA circular model is superior to all the existing time series techniques. So the last year, the American Statistical Association, American Statistical Association is the world's largest statistical association, one of the the second oldest and the largest statistical society in the world. So the last year, they published a blog about me. So there they have said that the SAMA circular model is superior to the existing techniques. The ARIMA is a well-known technique. So no doubt it is highly applicable in all the fields in the real life. And the decomposition technique also applicable, but it has some weaknesses. Among them, ARIMA was among all the time series techniques. ARIMA and SARIMA were the superior. But the American Statistical Association accepted the fact that the SAMA circular model is superior to ARIMA and SARIMA in real life applications. So without computer programming, I had no way of coming to that level. Actually speaking, that my finding, circular model and the circular indicator, it was in 2016, still 17, 18, 19, 20, only 4 years born. Only 4 years have gone. But it opened up a new world to me. I am not I'm with PhD, I only have passed 4 years. But I cannot remember how many conferences, how many places how many audience I address because of this circular model and SAMA circular model. I got invitations from a lot of countries. India is one of the top. So to explain the real life applications of mathematics, statistics, and my new findings. So far in last 2-3 years, I was invited by the Thailand, Malaysia, Australia, India. India was the first actually. India, Thailand, Malaysia, Australia, Singapore. So several times I have visited. It's this airports closed in last March. So I came from Australia on 9th March to go to another series of conferences in India, the Tamil Nadu. So the Pondicherry University and many other places. Usually, when I'm invited to India, they arrange it in a way that the several conferences they jointly invite me. So then in one round, I cover 5-6 conferences. So everything went like everything was upset due to COVID. However, like I got all these things because like compared to the senior professors, the PhD holders, having PhD for 10-15 years with a large volume of research publications, more than me, and with a lot of experience, I'm not proud of that, but that is the truth. Not even a senior professor has got chances like me, because all these invitations with all the facilities, I got the article and everything because of this new finding. So more than the economically, I really enjoyed that this cultural exposure. So India is one culture. Sri Lanka and India are almost similar. But the Singapore, Australia, Malaysia, they are different continents, different cultures. So I really got that foreign exposure, that the being with the people, seeing the world. I got all these things because of my new finding. Since I managed to do something new. But again, I am telling you, not with my mathematics and statistics. I did the development with maths and stat, but I had no way of bringing it to the real life without the computer programming. So then, my journey. It is the success of my journey depend on three things. Of course, being an all-rounder, that means I was not a mere scientist. I was an artist. I said from the beginning, so my life was balanced. So the creativity comes through that one. If you just do mathematics or statistics or chemistry or biology or your subject, you become a frog in the well. You won't see outside the box. If you want to see outside the box, you have to enjoy your life in those ways. So I was fortunate to be one of them. And with my mathematics and statistics, I developed something. Though I hate computer programming, I used to say I used to hate the computing. Still, it happened for me to love the computing since I have no other option. There was no other way of escaping. So I tried to love the computing. I tried to be with the computing, and now I really love computing. It was something let's say some people, for certain marriage, they don't like at the beginning. But since the parents are pushing, or since there is no other alternative, you agree for that. But later on, when you get with the person, you understand how nice this person is, how kind, loving and all, then you start really love the person. My love to computing also like that. Mathematics, of course, I love. From my small days, that was my favorite. I love mathematics. Not that I like mathematics, I love mathematics. In my life, I thought initially, from my small days, I was equally good in maths and the other art subjects like music, dancing, and all, writing and everything. So, there was a point where after my BSc, because of my father, I couldn't go for the social science, like the fine arts area. So, but after the first degree, I thought I will move to music. I have a music diploma from Bharathiar University, India, classical music violin. So I thought of moving into that side. I thought I love music and other arts. I am a good painter. I thought I love them more than mathematics. So in 1 year, that was after my first degree, I applied for a postgraduate, postgraduate in applied mathematics. And by the same time, there was a PhD in drama and theatre. So I applied for both and I selected for both. Then only I realized, okay, there was a choice for me. Am I going to go to math sides or my drama side? I thought I love drama more than mathematics, and with drama I thought of doing music also. But at that time I realized my love to mathematics is more than that side, drama or music. That day only I realized, okay, my heart is with mathematics. So I went to mathematics, and I did mathematics and statistics and got a PhD. Maths and stat, as I said, they are like almost the same thing. So I came to the top of that one, but I did not forget my music. After PhD, I started again learning my music. That means the drama, of course, I had to keep aside for a while. But now, at the moment, I am learning Indian classical music, the violin. So, those are the things I love. What I said is, be a balanced person. Do something you really love, but be a balanced person. Don't be Don't be a frog in the well. If you want to do something new, if you want to enjoy your life, you have to be a balanced person. But after all, the computing was the platform for my finding. I managed to bring it to the real life with the computer programming. Next slide, please. I will show you one application, one real life application of Sama circular model. I said circular model was the initial thing. If the data series has a trend, I cannot use the circular model. So the modified one, or the Sama circular model. This is one example of forecasting female unemployment of Australia. The first thing in this analysis, is identifying the pattern, or the pattern recognition. That is what we do in data science also. In data science, with the large volume of data, we find the pattern. Pattern recognition is a must. So when you look at this one, this time series plot, you can see it shows a high fluctuation. It looks like an irregular wave. Also, it has some trends. Certain parts, it shows increasing trend, the non-linear trend, linear trend, and everything is there in this data set. So the irregular wave, like pattern with trends. So that's what I observed in this female unemployment of Australia. Next slide, please. So actually, I thought of doing the practical with you, opening the Minitab from my side. So just for the reference, I put some slides into this one. Luckily, I did that one. I think due to this slide sharing problem, I cannot share the Minitab screen with you. So I will try to manage with this one. Now, hope you see this data set. I got monthly female unemployment rates. These are the monthly female unemployment rate from January 2009 onwards to 2018. So the female unemployment rates. Then go back to the previous slide, please. So this data series, it is like an irregular wave-like pattern. It has trends. So I said, if an irregular wave has a trend, we have to use the differencing technique. That's the way I used to capture the trend. That means keep the trend aside for a while, capture the trend and fit the circular model, then come back to the Sama circular model, including the trend. Next slide, please. So in this one, this screen you see, in column 5, C5, I have obtained the first difference. First difference is in Minitab. You can, if you have used Minitab, I'm showing the Minitab screen, not the Matlab programming or R programming. just I am showing you like how to do it in Minitab. Most of you are familiar with Minitab. If for one data set or two data sets, somehow you can manage with Minitab. But if you are handling large volume of data, of course you have to go for programming. So anyway, to give you some idea about the method and how difficult it is to use in Minitab, I will explain this example. Like then as the to extract the trend, I get the first difference. First difference is like yt minus 1, and I got the first difference and second difference series. Because I don't know for which one the circular model will be applicable. The which one, sometimes it may be first difference, second difference, third difference, or fourth difference. It can go up to that level. We don't know. Just I took first difference and second difference, assuming it will work. That means in the Minitab, when you go to calc, like from the look at the top of the screen, 1, 2, 3, 4. From left to right, fourth one is calc. To get the difference, go to stat. 1, 2, 3, 1, 2, 3, 4, 5. Stat. Next is stat. Go to stat. Stat. Yeah. If you click on stat, the down you will see all the statistical techniques. There you go to time series. Under the time series, when you click on stat, you can go to time series. From the time series, you can get the differences. First difference and second difference, third difference, and whatever it is, you can get the differences. So get the difference in series and store in your Minitab sheet. I mean, get the difference and store means it will be automatically stored in your column. Only thing is you have to specify the column. Next slide, please. So now I have, yes, see the time series plot of first difference series and second difference series. Now the trend is not there. In the original series had trend components, but now it is like a wave moving in a horizontal band. So both the first difference series and second difference series, they are wave-like patterns without trend. Now, first I have to check with first difference series. If it fails, or to get a better model, I might move to the second difference or third difference or fourth difference. What is first difference? I believe the yt and yt minus 1. When it comes to second difference, present, 1 leg behind, 2 legs behind. When it comes to third difference, 1 leg, 2 leg, 3 leg behind. So it might go up to high level. So anyway, we are starting with the first difference. Next slide, please. So the calculating the angular speed. I said in my model, I have to calculate the angular speed. Omega equal 2 pi simple f over capital N. That is, simple f is number of peaks in this graph. Professor, kindly take the pointer to any of the peak. Bring the laser pointer to one of the peaks. No, the previous slide itself. Previous slide. Okay, if it is difficult, I will explain this way. Now that you see, I have to calculate the number of peaks. I'm going to calculate, yes, now come down and go to the next peak. Next peak. That means 7th data point. So you can see there is a horizontal line through 0. The horizontal line through 0 if any point, like say this wave-like pattern, if this wave goes down, if this wave go below the horizontal line and cross the horizontal axis and come up, then we call it is a peak. That means like say 1, 2, 3, third point, it is a minimum. Fourth and fifth point, it is on the line, so we don't take it as a peak. Again, it is going down, and 1, 2, 3, 4, 5, 6, 7th point, it has, that line has crossed the horizontal axis and come up, so that is a peak, the 7th point. 7th point is a peak. Then 8, 9, 10, 11, 12 is a peak. So up to that point, there are 2 peaks. Likewise, if we are doing manually, if without a computer programming, if I am doing it, the few data sets I analyze this way, you have to count the number of peaks, but you can't just take the points above the x-axis. You have to make sure that wave, that line, connecting line has gone down and come up, crossing the horizontal axis. So that way, I assume you count. For one data set, you can do it. No, one data set, you count the number of peaks, and you know how many observations were in your data set. You count the number of peaks, simple F. Total number of observations in your data set, you know. Now I am going to calculate the angular speed omega. Next slide, please. Omega is 2 pi f over n. 2 into pi, that is 22 upon 7 into f is, in this one, if you count, you will see there are 22 peaks. 22 peaks in 90, some 90 odd observations, 107 observations or so. Yeah, 107 or 108 observations were there. Then 2 pi into 22 upon 108. That way I got omega. See the column C9, omega, or the angular speed is 1.2799. That is the angular speed of the particle. That means the motion of the particle. So then, to make the trigonometric series, I make the column T. There are 108 observations, so I make the column using the like the making pattern data. I made T from 1 to 108, and then made omega T. Omega T means omega multiplied by T. So 1.2799 multiplied by the column 10, I get omega T. Now, making the trigonometric series, because the sum circular model or circular model, we need sine k omega t and cos k omega t. So sine omega t, when you go to the calculator of the Minitab you have calc, go to calculator. In the calculator, you can select the function sine, and sine, first obtain sine omega t. Then sine 2 omega t, sine 3 omega t. Likewise, here see the small dialog box, there the calculator. From the calculator, under the function, select the sine. Then C11 is omega t. Put sine omega t, and you will get the values. Next slide, please. Yeah, that way, like first got sine omega t, then again go to calc, obtain like the select the sine function, then put sine 2 into omega t inside the bracket. That way I got sine omega t, sine 2 omega t, sine 3 omega t, 4, 5, 6. Right? Then cosine functions also needed, cos omega t, cos 2 omega t, 3, 4, 5, 6. Initially, as a rule of thumb, I normally start with, it's not a strict rule, you can go to any value, but I normally take k equal 1 to 6 for sine and cosine function. Then check the independence of these series. That means sine omega t functions and cos omega t functions. See whether they are independent. They have to be independent. Generally, they are independent. Then I go to regression. Next slide, please. So in Minitab, you go to Stat, then under Stat, you see the regression is there. See here, you can see this regression, ANOVA, DOE, control charts, everything is there, even time series. So you on Stat, select regression, then under the regression, you go to fit regression model. So when you go to that one, you can select the independent and dependent variables. Now, what is my independent variable? First difference series. Because I am doing all these things with the first difference series, not with the original series. So I am taking my independent variables, dependent variable as the first difference series xt, and the independent variables are these 12 trigonometric series. Next slide, please. So when running the regression, this regression box, this dialog box will be appear, and you as in the regression response variable, you put the first difference series, and under the continuous variables, continuous predictors, you click on sine omega t, sine 2 omega t to cos 6 omega t, and select. Then they will go to continuous predictor box. I mean the second box from the top. So those variables will be go to that box. Then you can have the storage facilities, error, and then the fits, residuals, graphs. All these things are there. You can click all these things, and you can select all these things and click OK. Then you will get the fitted model. Next slide. So this is the regression output. Look at the ANOVA table. Now the regression sine omega t, sine 2 omega t up to cos 6 omega t. Look at the p-value column. After this bubbles, after all, finding, counting peaks, calculating omega, and finding obtaining a trigonometric series sine omega t to sine 6 omega t, cos omega t to cos 6 omega t. After all, I ran the regression model, and the p-value of regression is not significant. P is not less than 0.05. That means my regression model is not significant. With this obtained sine omega t to sine 6 omega, the sine omega t to cos 6 omega t, I tried with 12 independent variables to model the this xt, the first difference series, but none of the p-values are less than 0.05. That means my method fails. Then what to do? Now see how long it takes to make these data series and run this one. Then there is no other alternative. Like there are several steps to be taken. You can, now that you did it with the first difference series, so you take the second difference series. Again, calculate omega. How? Counting the peaks. Taking omega is 2 pi f over n. Calculate omega and obtain omega t. Then sine omega t to sine 6 omega t, cos omega t to cos 6 omega t. And after all, again you run this one. So when I did this, like that, with sometimes, if you are lucky, at least one or two series will be, one or two independent variable be significant. But sometimes none of them will be significant. Then what you have to do is, like I said, the sine k omega t and cos k omega t. K is a positive real number. It is not an integer. So you must try with k equal decimals, like k equal 0.5, 1, 1.5, 2, 2.5. You can split. You can take the fractions for k. Even you may take 0.1, 0.2, 0.3 up to 1, then 1.1, 1.2. What a large number of data series you have to make. If you are going to do it manually using Minitab or Excel, it is killing. Even counting those peaks is a headache. Sometimes when the point is just above the line, you don't know whether to take it or not. So, after all, it is a hassle. Like with one data set, testing the model for one data set itself is a problem. So then, what to talk about 100, 200 data sets? Still, remember, this method is superior to all the existing techniques. So you can't just ignore it as it is superior to all the existing techniques. What is the solution? So simple. Write a computer program, like as I did in PhD. I wrote a simple program in Matlab to count the peaks. Define the peak in a way, count the peaks, and obtain all the series just with one line and testing the model. Even the normality and independence also being tested. So that way, in no time, we can run the large number of models. Even k equal 0.1, 0.2, 0.3, we can obtain all the series and run the model. And Matlab programming, I use Matlab. As I said, I learned both Matlab and R, but for some reason or the other way, I like Matlab more than R. So I use Matlab, but when it comes to R, you can use R also for the same purpose, and R is freely available. Matlab is not. Matlab is expensive. Like you can download a trial version for 1 month. Other than that, unless you get it from a university or some other person, buying is quite expensive. So other way around, R is freely available. So you can write a program in R and do this analysis. It's easy. So now the Python also there. So now in data science, generally data science, the mainly used things are R and Python as they are freely available. But a lot of people use Matlab also. Still, I prefer Matlab. I don't know, there is no specific reason, but I like Matlab. I have found I have the software, so you can use R or Python or Matlab to write a program and run this model. Please, next slide. So with my Matlab program, I found this as the best fitting model for the purpose. Yt equal yt minus 1 minus 2 times yt minus 2 plus a constant plus some constant into sine 2 omega t plus constant into cos 0.5 omega t plus constant into cos omega t. So that means here see, I tested with the decimals also. K equal, I think as I could remember, I take K from 1 to 6, taking each decimal, 0.1, 0.2, 0.3, likewise. I took large, I obtained, I wrote the program to obtain all these series and run the model. So this was the best fitting model, and the errors were normally distributed and independent. And the measurement of errors were very small, like around 1. Measurement of errors were extremely small. So I selected this as the best fitting model. So you can see this was the best fitting model was related to the second difference series, not with the first difference. If yt equal yt minus 1 is that is first difference. But here we have the lag, that means the present unemployment. What does this mean? Present unemployment, YT, depend on 1 lakh unemployment. I use month data, that is previous month unemployment rate, and the 1 month before the previous, that 2 lakh variable, and it follows wave-like patterns. It comprises 3 waves, sine 2 omega t, cos 0.5 omega t, and cos omega t. So it comprises 3 wave-like patterns. So these wave-like patterns, you know, those who have used ARIMA and SARIMA, you know, if the data series has seasonal pattern, you can capture it by ARIMA, but you have to specify the seasonal length. When running the seasonal ARIMA, you have to specify the seasonal length. It's trial and error. If It is one disadvantage. It is a trial and error. Even decomposition technique, you have to specify the length. But in this method, you don't need to specify any seasonal length. Even the SARIMA is unable to capture the cyclical variations. Where it is available, it is there in time series, but the cyclical variation cannot be captured by the SARIMA. And the decomposition technique also unable to capture the cyclical variation. Still, this Sama circular model is capable in capturing both seasonal and cyclical variations as well as the trend. Trend is captured by the lag variant. Next slide, please. So this model, as I said, it comprises three trigonometric functions. So if you find the period of oscillation is the time taken to complete one cycle. If we find the period of oscillation, like when I did it, I found that period of oscillation of sine 2 omega t function was 6 months. Period of oscillation for cos 0.5 omega t was 19 months, and cos omega t was 10 months. That means the unemployment of Australia follows both seasonal and cyclical patterns. How? If the period of oscillation is 12 months or below, it has seasonal pattern. If more than 12 months, it is a cyclical pattern. That means it has two seasonal patterns, 6 months and 10 months. Also, it has 19-month cyclical variation. Again, I am comparing it with the SARIMA. SARIMA, you can capture only one seasonal variation, but this has two seasons. If you think about the seasonality, just think about tourism. Our countries, we are like thinking about the tourism income. So the tourism, it has sometimes there are one major season and one mini seasons. So with SARIMA, or the decomposition, we cannot capture both seasons. But this Sama circular model is capturing seasonal, cyclical, and many seasonal or many cyclical variations without any effort. So I will show you the plots in next slide. Next slide, please. This is the plot of sine 2 omega t. For the convenience, I took it from the Minitab. Sine 2 omega t. If you count, just take carefully take one wave. That means one complete cycle. So the number of dots in one complete cycle here is 1, 2, 3, 4, 5, 6. That is the period of oscillation is 6 here. Next slide, please. That is the plot of cos 0.5 omega t. Here, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, yeah, it is the one with 19 points. One complete wave is 19 points. Next. It is the plot of cos omega t. Here, if you count, you will see the period of oscillation is 10. That means, like, even to count these things, you can use the your computer program. So that way, like, easily you can find whether this data series has trend, seasonal component, cyclical component, and what are the lengths of seasons and cycles. So all the information about the time series is found easily. Next slide. Another example, I'm not going in brief, going into details. This is forecasting consumer price index of India. I just showed the time series plot and best fitting model. So this plot also shows an irregular wave-like pattern, but see, like in the unemployment case, it shows high fluctuations. But here, there is not that, the fluctuation is not that much. As you look at the graph, you see a trend, kind of a linear trend. But when you fit the model, you see it depends on consumer price index. This month index depend on last month index and two trigonometric functions, sine 1.25 omega t and sine 3 omega t, based on three trigonometric functions. So, even if it is not visible that much, like here there were no cyclical patterns, it had only seasonal variation. So, likewise, for initially, I developed the method circular model and improved the circular model and for the Sama circular model to forecast the share market. Still, later I found that it is applicable actually by the theoretical proof, not only for the share market, for any irregular wave-like pattern, the circular model and Sama circular model are applicable. So by the time I have tested, I and some other researchers have tested for many fields of studies. Simply speaking, any irregular wave-like pattern with trend or without trend, you can make use circular model and Sama circular model for reliable and accurate forecasting. So, again I am telling you, my success was depend on mathematics, statistics and computer programming, computing. To handle the large volume of data, the only help was the computer programming. Therefore, if you want to become a good scientist, or if you want to become a data scientist, be master in all these three areas. Most of you are, as I heard, most of you are from mathematics and statistics background. Even if you are not a mathematician or statistician, maybe you are from biology side or economic side or some other area, learn some mathematics, some statistics and some computer programming. I am not telling you to do a master degree in maths, master degree in stat, then the master degree in computing and become a data scientist. That is impossible. No one can do like that. Even it happened for me to do a master's in business administration, not that I wanted to do it. So learn some maths, some stat and some computer programming. That way, because by the definition, the data scientist is someone who is better in statistics than the software engineer and better in statistics than any software engineer. So you must be good in maths, stat and computing. Though that definition does not have mathematics, statistics purely depend on mathematics. And even with from my experience, my example, you see, if I was just a statistician, I can't make this miracle. I can't develop these good models. My mathematics knowledge, I combine with the physics and other things. That's how I developed this thing. Next slide. So if you want, I did not put the references of my talk as it is, there are large number of references. Go to this one. This is our company website, Institute of Mathematics and Management website. There, under my profile, you can find the applications, my application. Other researchers also have done, but you can find my applications of circular model and Sama circular model in this one. So, in any future research, if you want my support for data science, you can contact me through our website or using my email address. Next slide, please. So finally, what I have to say is, practice makes perfect. Within one day or 1 week or 1 year, you cannot become master. You cannot become a world-recognized researcher, world-recognized scientist. Practice. And the other thing I have to tell you is, I have become a world-recognized statistician, mathematician, but I never aimed for that. Recently, one lady from Sri Lankan University phoned me and said, Madam, I have done some new development, and explain it. So I was patiently listening, and she was explaining, and finally she said, I asked, okay, I understand that you have done something good, but what do you expect from me? Then she said, Madam, can't your institute give me a Best Scientist award? I got a shock. Are we going to find the Best Scientist award? I got a Best Scientist award from India, but that is Andhra Pradesh, in one university, one conference in Andhra Pradesh, 2019. So until mine, I was invited as the two conferences were there. One is invited speaker and one is keynote speaker. So the same place. One is biological science and one is mathematical. So I went there as the chief guest and the speaker. I never knew about this Best Scientist award. When my name was announced, only I got to know that I have this kind of award. It has to be like that. I was so happy for my recognition, for my that was awarded for my circular model and summer circular model, for my contribution to the field of statistics. I bothered about doing something new. So I did not think about this awards or anything. Remember, do your job properly. Try to contribute something to the world. Then money and other stuff will come behind you. If you are going behind the money or prestige, those things also running away. You are trying to reach the money, you are trying to reach the honor, you will never be able to reach them. Do your job properly. Be a genuine researcher. Don't be p-value hackers or data thugs. So don't change the data set to achieve what you want. Don't misuse statistics or computing to achieve something. Genuinely do your job. Then the world is open for you. The sky is unlimited. You can fly. You will get the chances to fly. But practice makes perfect. And the Institute of Mathematics and Management slogan is determined, dedicated, and done. I said my PhD took 8 years. Being patient for 8 years, what happened was, that is a PhD in statistics, but application in stock market. My university, initially they also didn't understand the gravity of this. They accepted me, and after some times they realized that they cannot find a supervisor who is knowledgeable in math, stat, and financial markets. So they asked me after 3 years. They told me to stop the PhD as they cannot find a supervisor. Imagine, after 3 years work, they were suggesting me to go to another university and start another PhD, or change this topic and do another PhD. I said, no, I am not going to. So I like one of my friends, someone who was quite good in mathematics and finance, he's a finance professor. He said, why don't you do an MBA and bridge and fill the gap? Doing a master's in business administration as a maths and stat person, management is like a Greek for me. But no alternative. I can't turn back. So I started doing the whole PhD and started master's in business administration in some other university. Likewise, it took 8 years. So that time I was really unhappy, frustrated. So I got all the sicknesses, constipation, high blood sugar, and this and that. Still, I managed to do something to the world. That pleasure is there. More than any award or more than any other material gain, that happiness is important for me. So we couldn't start as we planned due to technical problems. Even I was thinking to do some the Matlab practicals with you, to introduce you Matlab programming. But now that 1:12, I know you all are hungry. So I'm not going to continue this one. And anyway, I can't do the screen sharing also. We'll see you in some other time with the programming and some other thing. Okay then, Professor Gandhiya, thank you very much for inviting me. And the listeners, thank you very much for listening to me. And thank you for everyone.
Thank you, ma'am.
Yeah, welcome.
Now, if you have any doubts, you can clarify with madam.
Feel free, any questions?
You can just unmute and talk to
yeah.
madam.
Good afternoon, ma'am. It was very motivational. Actually, your growth itself is motivational to others. My question is, in the stock markets, most of the time people lose money.
Hello.
Hello, madam. Am I audible?
Yes, sir. Audible, sir.
Yeah. My question is, most of the time people lose money when trading stocks actually. So I don't know whether it's a part of your research or not. I am just curious to know whether there is a model to predict any company is going to stop trading in 1 or 2 years or something like that.
With this model, let's say if you are applying this for the share market forecasting, you can, like individual companies, you can see let's say 5 months time, what will be the return? In 6 months time, what will be the return? By looking at the return and using the circular indicator, you can see the risk. So by looking at them, the investor can decide whether to invest in this company or not. Even the trend is there. With the trend, you can see how this company is going on. What is the direction of the motion of this company's share trading? So we don't know for sure whether they will stop trading, they will stop selling their shares in the market. That is the management decision. But we can see what is really going to happen in the market.
Oh, yeah, got it, madam. Thank you.
But not only stock market, more than the stock market. Now I showed you one example in unemployment forecasting, then the consumer price index. This is applicable for any field.
Yeah. Thank you, madam.
Welcome. Any other questions?
Resource person madam is waiting. Any regarding to for your queries?
If anybody has any doubts, like if they want to clarify later, share I don't mind you sharing this slide set with them. So my email address is there, so they can email me, or they can they can email me easily for any future research of them, either their academic research or any other research. We are Institute of Mathematics and Management, willing to help you, not at a profit. Knowledge has to be shared.
Ma'am,
good evening, ma'am.
Good evening.
Yeah, I have a doubt, ma'am. These approaches you can apply for the SIP data share market, ma'am.
Please repeat it. I didn't get the question.
We can apply for the approaches the data stock market SIP method.
Which method?
You can apply for the approaches.
Systematic investment plan he is talking about, madam.
Systematic investment, yes. Like what has to be, the only requirement for this thing is the data set should follow irregular wave-like pattern. For any data set, in any field, any data set, if your data set is with a trend or without trend, if it has a wave-like pattern, what do we mean by the wave-like pattern? Fluctuation or the volatility, then you can use these models.
Yeah, thank you, ma'am. Thank you so much.
there are no more questions, shall we stop there?
No more questions. Otherwise, I wind it the formal vote of thanks. That time, dear participant, any more questions? Okay. Okay. Thank you, ma'am. Thank you very much. A long time we see for associate with in
You're
this
warmly
program,
welcome.
ma'am. Yes, ma'am. So, ma'am is the given the focus of area around touching all area, mathematics, statistics, computer science, and also the financial management issues. They're based on the real-time application and associate with the for the right now is budding young scholars and the UG PG students is the very useful in this session. So once again, thanks you, ma'am, given the today lectures is very wonderful, and also once again thanks to accept my invitations. The based on I given the send the invitation for WhatsApp immediately accepting, ma'am. So I am happy to the at the moment. So also very engaged of today's sessions, ma'am. Thank you very much, ma'am.
Thank you so much for inviting me. Ayubowan, may you have a long life.
Yes, ma'am. Yes, ma'am. Definitely, ma'am.
In my language, Ayubowan means may you have a long life.
Okay, thank you, ma'am. Okay, ma'am. Thank you very much, ma'am.
On behalf of Jamal Mohammed College, I thank everyone, and also I thank Madam for giving this lecture. Thank you, ma'am.
Yes,
Request to please share the slides of ma'am and the email ID as well.
Okay, ma'am. So today is the grand success of day 3 on March 17th, 2021. On behalf of organization secretary, myself, Dr. Gandhiya Vendhan, organization secretary, Department of Statistics, Bharathiar University, and the program is also associated with PG and Research Department of Mathematics, Jamal College, Tiruchi. Once again, thanks to both authorities, University of Authority, Honorable Vice Chancellor, respected Register, and the Department of Statistics, and also respected principals and head of the Department Mathematics, Jamal College. Thank you, sir. Thank you very much, sir. Sir, yes, post of attendance, ma'am. Today attendance, sir. Sir. Sir, is there? Yeah, post today attendance, sir.
Attendance, sir.
Attendance post பண்ணிருங்க சார்.
சார்
அட்டெண்டன்ஸ் போஸ்ட் பண்ணிட்டீங்கன்னா பிரச்சனை. நான் ஃபீட்பேக் போஸ்ட் பண்ணிட்டேங்க சார். அட்டெண்டன்ஸ்
வெந்தான் சார்.
ஓகே ஆட்டோமேட்டிக்கா பண்ணிட்டீங்களா? ஓகே நோ ப்ராப்ளம் சார். நோ ப்ராப்ளம். Tell me, sir.
Sir, actually I am my email ID is raghavendra@manipaldubai.com, but I am attending this session with raghavendra@dxp.manipal.edu. So you may see the difference.
Okay, problem. Sir, attendance is automatically attendance, sir. No problem, sir.
Okay, fine.
Microsoft Teams is automatically attendance is there, sir.
Okay.
That is fine. When you joined, when you leave, we got time and left. We know all the details of.
Emails are different. That's what I want.
Yeah, okay, no problem, sir. You fill the feedback from every day, sir. Okay.
Yeah.
The video file.
Thank you, sir.
Thank you very much, sir.
Video file.
I think sir,
எப்படின்னா அந்த ஃபைலுக்குள்ள போயிட்டு அந்த லெட்டர் எல்லாம் இது பண்ணி அந்த கலர் எல்லாம் மாத்துறதெல்லாம் அந்த எழுத்து எப்படி மாத்துறது எல்லாம் பண்ணி பிபிடி மாதிரி
So
போடுவோம்.
tomorrow is foreign delegates, so come early. That is I request for organization secretary. Okay.
வேர்டு இதெல்லாம் எழுதி இது பண்ணு. அது மட்டும் அது அவ்வளவுதான். புதுசா பண்ணணுமா வேர்டு மாதிரி புதுசா எழுதணும். சும்மா எழுதி கலர் மாத்துறதுலாம் ஸ்கிரீன் ரெக்கார்ட போட்டு அதுல காமிச்சுடணும். எதுக்கு அது மார்க்கடா அதுக்கு நம்ம எடிட் பண்ணி சப்ஜெக்ட் எடிட் பண்ணனுமா? அதான் இதுலயே பண்ணிக்கலாம். வரணும் இதுல வந்து என்னதுல நேத்தே டைம் முடிஞ்சு எப்ப பண்ணுவோம்? நைட் நேத்தே முடிஞ்சா?
சார் ஜமால் சார் மீட் பண்ணிட்டு பேசிக்காங்க சார்.
சென்ட் பண்ணுங்க ஃபைல் சென்ட் ஆகும்.
சார் ஜமால் சார்